Let's talk about some important terminology that's associated with alkenes. You can see on the slide the use of the term vinylic carbons. sp2 carbons of an alkene are called vinylic carbons. An sp2, or rather an sp3 carbon that is adjacent to the vinylic carbon is called an allylic carbon, as indicated here on the slide. These two are sp2 hybridized carbons. This is an sp3, this is an sp3 that's directly bonded to an sp2 vinylic carbon. It is therefore an allylic carbon. The vinylic carbon is sp2 because it is binding to only 3 other atoms. The allylic carbon is sp3 because it is binding to 4 other atoms. For example, this sp3 has 2 hydrogens. It's also bonded to that R group, and it's in addition bonded to that carbon for a total of 4. This carbon, sp2, is bonded to this 1 hydrogen, bonded to that 1 carbon, and bonded to this other carbon for a total of 3. Let's take a look at the next slide. Additional terminology that's used. Here we go. Vinyl group is the smallest group that contains a vinylic carbon. The allyl group is the smallest possible group that contains an allylic carbon, as shown in the top of the slide. Here is the vinylic carbons, that one, and this is the vinyl group, the smallest group that contains the vinylic carbons. Here is an allyl group. This is the allylic carbon right here. This entire group is called the allyl group. And looking at the naming of these compounds, you can see systematic name and common name. This is chloroethane or vinyl chloride. Vinyl chloride is a common name that's associated with this compound known very commonly in industry as vinyl chloride, a very toxic compound. Here's 3-bromopropene. Notice 3-carbon chain. Bromine is bonded to number 3 because the double bond is between 1 and 2. So 1, 2, 3. Or its common name is allyl bromide. Why is there no number on the prefix of chloroethane, but there is on 3-bromopropene? Okay. Now on chloroethene, you can see that there's only 2 carbons. So the double bond is always going to be between 1 and 2. And it really doesn't matter where the chlorine is. We don't need to put a 1 because it's going to be on number 1 either way, either side, this one or this one. Whereas with 3-bromopropene, we have 3 carbons, and the bromine could be on number 1, could be on number 2, it could be on number 3, it could be on number 2, or it could be on number 1, because this is number 1, 2. In order to have the double bond numbered 1 and 2, that has to be 3. But you can see, because in chloroethene, there are only 2 carbons, and they will be 1 and 2. Chlorine is assumed to be on number 1 carbon, so we don't indicate that in the name. Okay, let's look at the next slide. The next series of slides are just practice naming alkenes. What is the functional group? Obviously, it's the double bond. So to name this compound, we're going to name it to get the longest chain with the double bond and also to put the lowest number on the double bond. So looking at this molecule, it could be 1, 2, or 1, 2, 3, 4, 5. So it would be between 3 and 4, but if we number this way, 1, 2, 3, it would be between 2 and 3. So we can name it 2-pentene, and of course, 1, 2, 3, 4. Methyl group is on number 4, so we name it 4-methyl 2-pentene. The next example, you can see, name this compound. Again, we look for the longest chain that contains the double bond. Notice it's in the middle of the molecule, 1, 2, 3, 4, 5, 6. So it's between 3 and 4, or 1, 2, 3, 4, still between 3 and 4. Therefore, we're going to name the compound to get the lowest numbers on the substituents. We have a chlorine and 2 methyl groups. Chloro is going to come first in the molecule, so we're going to number to get the lowest number on the chlorine. 1, 2, 3, 4. So it's going to be 3, 4 dimethyl, and it's also going to be 1, 2, 2 chloro. So the name is 2 chloro, 3, 4 dimethyl, 3 hexene. Here's another example. Name this compound. Notice we have a cyclic structure, 5 carbon. It's a pentene with a 1 double bond. Of course, the double bond is between 1 and 2. If we can get 1 onto the bromo group, that would be great. So we'll number it 1, 2. So it's going to be 1 bromo cyclopentene. We don't have to designate where the double bond is because it's assumed to be between 1 and 2. Another example, name this compound. Notice again, we want to number it so we get the lowest number on the double bond, if possible. If we number it this way, 1, 2, 3, 4, it's between 3 and 4. We number it this way, it's 1, 2, 3, 4, it's between 3 and 4, so it's a tie. We look at the substituents. We have a methyl group right here. We have a bromo group right here. B comes before M in the alphabet, so we're going to try to get the lowest number on the bromo group, as you can see. So 1, 2, 3, 4. So it'd be 1 bromo, 4, 1, 2, 3, 4 methyl, 3 hexene is this compound. The next example, name this compound. It's an alkene, cyclic structure, has 2 methyl groups. We want to number in order to get a number 1 on one of the substituents. Of course, the double bond must be between 1 and 2, so to get 1 on one of the substituents, it's going to be number 1 will be this carbon. Therefore, that must be 2, because the double bond has to be between 1 and 2. We can't go 1, 2, because then the double bond would not be between 1 and 2. So 1, 2, 3, 4, 5, 6. So the name of the molecule will be 1, 2, 3, 4, 5 dimethyl cyclohexene. And again, we don't have to say where number 1 is because it's always between 1 and 2. Here is another example, the last example. Name this compound. Notice we have an oxygen, so immediately we know we can name this as a substituent since the double bond is the functional group, and it's in a 3-carbon chain, 1, 2, 3. Then we have the substituent, but again, it's between 1 and 2, and to get the lowest number on the substituent, we'll number it 1, 2, 3. So it's going to be a 1 propene. It's going to tell us that the double bond is between 1 and 2. And also we're going to use 1 in the name because it tells us where the butoxy group is. 1, 2, 3, 4. The butoxy substituent is bonded to number 1. 1 and 2 is where the double bond is, and we're going to call that number 1. So the name is 1-butoxy, 1-propene. That concludes our examples of alkenes.